Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to continue our discussion on word problems, but the word problems are going to look a little different than the ones we did before. As you can see from the title, our word problems here are going to be with variables on both sides of our equations rather than just one. Before we get there though, let's do a little do now to review a type of word problem we've talked about before. So it says Jessica went to the store to buy oranges and apples. She bought the same amount of each fruit. Each apple costs $1.10, and each orange costs $1.25. She spent $25.85 total. So you need to write an equation that represents a scenario. You're allowed to choose whatever variable you'd like, but you must state what it represents. And then you're going to find the number of apples and oranges that Jessica bought. So pause the video, give that one a shot, and then come back and see how you did. All right, so let's think about what it tells us. It tells us she went to the store to buy oranges and apples, but she bought the same amount of each fruit. So if she buys 10 oranges, she's buying 10 apples, or 8 and 8, or 7 and 7. Each apple costs $1.10, each orange costs $1.25, and she spent $25.85 total. So again, the number of apples, or the cost of the apples, maybe I'll do that in red because apples are not orange. So we have cost of apples plus the cost of oranges equals the total cost. But before we substitute in any variables and numbers for our word equation, we need to actually have a variable. So it doesn't give us a variable, but it does tell us what we're trying to figure out. So it says find the number of apples and oranges that Jessica bought. Because that number is the same, there's not going to be a different number of apples than oranges. So the thing that we're trying to find is going to be our variable. And I'm just going to use F for fruit. So let F represent number of apples and oranges that Jessica buys. And I don't mean apples and oranges combined. I mean F will represent the number of apples, and it will also represent the number of oranges. So the cost of the apples is going to be the number of apples times $1.10. So 1.10 times F plus the cost of the oranges is 1.25 times F. And we are told that our total cost is equal to $25.85. So now we just have an equation to solve. There are decimals, but we can do that. If I combine my like terms, I end up getting 2.35F is equal to 25.85. And if I divide both sides by 2.35, I am going to get 11. So F equals 11. That means she buys 11 apples and 11 oranges. So again, just a review of a previous type of word problem. All right, let's jump into the new stuff for today. So it says in our last lesson, our equations had variables on only one side. In today's lesson, the variables may be on both sides. So we need to look at the problem given by the picture to the right, and then we'll talk about what we need to find. So it says some friends want to see a movie that is showing at 2 different theaters. They plan to share 3 tubs of popcorn during the movie. So no matter how many friends go, they're going to get 3 tubs of popcorn to share. And you can see that we have movie theater A, and then we have movie theater B. And they have different prices for each ticket, and they also have different prices for a bowl or a tub of popcorn. So what we're trying to do is we're trying to find the number of friends for which both theaters will cost the same amount. So if I had 5 friends, would theater A cost the same amount for them to go to as theater B would? Or maybe it's 6 friends, or maybe it's 9 friends. We need to find that amount of friends where both theaters would cost the entire group the same amount. So my hint is, if we want the price of each theater to equal each other, set up an equation where the expression for the cost of one theater on the left is on the left, and the cost of the other theater is on the right. And I tell you to use X to represent the number of friends going to a movie. So here's what I mean by that. I need theater A, or rather the cost of theater A to equal, we'll use purple, the cost of theater B. So now we just have to figure out what is the cost of a certain number of people going to theater A. Well, we know that they're going to buy 3 tubs of popcorn regardless, right? So we can do 3 times the amount of 1 tub, so 3 times 5.75. That's the cost of the popcorn, right? Then we have the cost of the tickets. Well, we don't know how many friends are going, but we do know that each ticket costs $14.50. So $14.50 is the price for 1 ticket, and if I need to find the price for a random amount of people, that would be 14.50 times X, times our variable. So if there were 2 friends, we'd multiply that by 2. If there were 3 friends, we multiply that by 3. The cost of theater B follows the same setup, right? We're still getting 3 tubs of popcorn, so 3 times 6.75. And then we have the cost of the tickets. In this case, it's only $13, not $14.50, so it's plus 13x. So we have for each theater the cost of the popcorn. And let's actually put this out here. So we have the cost of the popcorn for both. And then we have the cost of the tickets for both. And if you wanted to do popcorn plus tickets equals popcorn plus tickets before you came up with your numbers and variables, that's perfectly okay. Now we just have to solve, right? So I'm going to go over here to solve. First thing I'm going to do is just simplify both sides of each equation. So I get 17.25 after I multiply 3 times 5.75 plus 14.50x is equal to 20.25 if I multiply 3 times 6.75 plus 13x. So the first thing I'm going to do is I'm going to subtract 13x from both sides. So I'm going to get 17.25 plus 1.5x. You can do 1.50 if you want to. It does not make a difference. Again, I just subtracted 13x from both sides. On my right-hand side, I'm just left with 20.25 because 13x minus 13x is 0. Then I'm going to subtract 17.25 from both sides. So I'm left with 1.5x on my left-hand side. That is equal to 3 on my right-hand side. 20.25 minus 17.25 is equal to 3. If I divide both sides by 1.5, that is going to give me 2. So the number of friends where the theater will cost the same amount is 2. And we can put a little label on there, 2 friends. So the problems in today's lesson are going to deal with us setting things equal to one another. So we're going to have 2 equations, one on the left-hand side, well, not 2 equations, but 2 expressions. In this case, it was theater A equaling theater B. We're going to come up with expressions for both of those things and then just set them equal to one another. So let's try one more. And we're actually going to go down to one of these ones at the bottom because they're slightly different than what we've done. So we're going to go down to number 6. So it says a red balloon is 35 feet above the ground and it's rising at a rate of 2 feet per minute. At the same time, a blue balloon is at 130 feet above the ground and descending at 3 feet a minute. And then we need to figure out after how many minutes will they be at the same height. And then we want to find what will the height of both balloons be when they are at the same height. So this one is conducive to drawing a diagram. So let's do a red balloon here. That'll have to suffice for a balloon. That is 35 feet above the ground. And it is going upwards at a rate of 2 feet per minute. We also have a blue balloon, and that is 130 feet above the ground. And that is going downwards. Let's put that 130 on the other side just so we're not confused. And the blue balloon is traveling downwards at a rate of 3 feet per minute. So eventually they're going to be at the same height, right? If one's rising and one's falling. So again, because we're looking to try to find the height at which the balloons are the same, right? We want the height of the blue balloon. So we'll say height of blue. We want that to be equal to the height of the red. And now we need to think about, okay, before we try to write our equation with variables and numbers, we first need to come up with what our variable is going to be. Well, the first thing that they're asking us is, after how many minutes will the balloons be at the same height? So the amount of minutes is an unknown, which means we can use a variable to represent that. So I'm going to use m for minutes. So we'll say let m represent number of minutes. So after 1 minute, the red balloon will be at 37 feet above the ground because it's traveled upwards of 2 feet. And the blue balloon will be at 127 feet because it will have decreased its height by 3 feet. Okay, so the height of the blue balloon. It starts at 130. Because it's descending, we're going to be taking away, or we're going to be subtracting feet off of 130. All right, so keyword here is the blue balloon is descending at 3 feet per minute. So we're subtracting 3 feet every minute, or 3 times m. So 130 minus 3m. The height of the red balloon, well, we start at 35, but then we're increasing that height. So we're saying plus 2m, or plus 2 feet per minute. Okay, so again, I'm confident that you can solve this equation, but the tough part is setting it up. So if you're still unsure of where this equation came from, this one right here, pause the video, go back, listen to what I said about the diagram again, listen to what I said about the variable, and listen to what I said when I set up the equation. Do that before you go ahead and solve it. Once you understand where we get the equation, we can then solve. I'm going to subtract 35 from both sides. So that's going to give me, oops, I'm on my eraser. So that's going to give me 95 minus 3m is equal to 2m. Again, I just subtracted 35 from both sides. Now I'm going to add 3m to both sides. So I get 95 is equal to 5m. And then I'm going to divide both sides by 5. So I'm going to get m is equal to 19. So at 19 minutes, the balloons will be at the same height. The red balloon will have traveled up, the blue balloon will have traveled down, and they will meet somewhere in the middle. That's not the only question they're asking us, though, right? They're also asking us, what will the height of both balloons be when they are at the same height? Well, to figure that out, we can either choose the red or the blue balloon. Let's choose the red. I'm going to have to get rid of some of this work just because I don't want to have to scroll down and you not be able to see the problem. So I'm going to erase our picture, but you will still have it on your page to reference. And I'm actually going to write a little sentence for part A. So we can say the balloons will be at the same height after 19 minutes. It's good to write that little concluding sentence, even though you did the work down here. Just explain to the reader what that 19 really represents. So part B, what will the height of both balloons be when they are at the same height? Well, we can just choose the red balloon. So the red balloon started at 35 feet, and it went up by 2 feet per minute. So 2, and instead of m, we can write 19, because we're doing 19 minutes. That is equal to 35 plus 38, which is equal to 73 feet. So both balloons will be at 73 feet after 19 minutes. Height of both balloons. Oops, it's not how you spell balloons. After 19 minutes. Okay, so we've covered the two types of problems that you will see throughout today's lesson. I'd encourage you to go work through some of them, see if you're able to figure them out on your own. If you have questions, of course, write them down so we can save them for a discussion. Okay, this has been Mr. Fawcett. I hope you enjoy the rest of your day, and I look forward to seeing you for our next video.